Hello everybody, this is Subhrangshu from the GSE Cloud team, and today we are going to present high availability with Helion OpenStack using 3-par peer persistence. So Sunita and Bhaskar from the GSE Cloud team is going to present this. I'm going to briefly talk about the background of this work and how we uh, ended up doing this. So there was a Indian cloud uh, provider who was interested in VM level high availability on OpenStack, and we thought that 3-par peer persistence fits into his requirement quite well, and we started working on this. Um, Whatever we are going to show today is not officially supported, and there is not much of a elaborate documentation around it. So we thought of making this video so that it helps people who are interested in implementing HA with Helion OpenStack using 3-par peer persistence. I'll quickly outline what we are going to do now. So this is the setup where we have two 3-par arrays spread across 2 floors of a data center. It could be 2 different data centers also. And you have a VM which is of your interest, which is running on a RHEL compute node. And I start with a stage where your VM is actually connected to a primary volume, which is there in a remote copy group, and your replication is actually going on. At this point, your P volume, which you see on the left, is your primary volume, and S volume, which is on your right, is your secondary volume. Your VM is actually booted from this primary volume, and it is treating S volume as the secondary one. Now, I am showing a case where your 3-par 1 goes down. Immediately, you lose connectivity, and what happens is your replication stops. Now, once your replication stops, your quorum server, which we have kept it at a different power supply, because it's very important to keep the quorum server alive. It detects, it actually initiates a failover. Once it initiates the failover, basically your secondary um, volume actually, the 3-par 2 actually initiates a failover, and your secondary volume becomes your primary volume. At this point, your switchover is complete. Once your switchover is complete, your VM actually treats the secondary volume as the primary one, the S1, which was previously the primary volume, and your P volume as the secondary one. This whole process is quite seamless. We'll show that there is absolutely no uh, problem in the VM whatsoever. You don't lose connectivity, neither you lose anything going inside the VM. Having said that, I'll pass it on to Sunita, who will go over the details.
Thanks, Subbu. I'll explain what is needed from HP Helion OpenStack in order to use the feature of 3-par peer persistence. So Cinder needs to be configured to use the backend as 3-par, and the volume type needs to be created appropriately. And go to the volumes tab in Helion OpenStack and create a volume from the 3-par backend. Say create volume. So give a name for the volume. Source as image because we need a boot volume created. Choose the image. Make the volume type selection, which will say create from the 3-par backend. So this takes a while because it's creating volume from image. It needs to download the image and create the volume. So now you can see the status is downloading, and once it's complete, you will see it as available. So now the volume status is shown as available. So what is next is go to Nova and say launch an instance from the newly created volume. So click on instances under project tab. So say launch instance. Give a name for the instance. Boot source, select as volume because we are going to boot the instance from the volume that is in prepar. So this lists the newly created volume. So select the boot volume. Say next. Select the flavor. Select the network. Select the security group. So I'm not using any specific key pair, so I'm not making any selection here. Say launch instance.
Sunita, maybe.
So the instance is active now, and we need to assign a floating IP to this instance. Go to associate floating IP. So get an IP allocated from external network that where the instance has the network internet access. Say associate. So the instance is launched with an IP of 10.10.40.53. So I'll pass it on to Bhaskar to show the peer persistence part.
Yeah, Sunita, just before that, I would like to get some more details about that volume ID from the Helion thing.
So if we click on the instance, it will show the volumes that is attached. So click on the volume. So ID is 9AC, starts with 9AC and ends with EF.
Okay, thanks, Sunita. The reason why I asked this is the volume that will be created in the 3PAR, and we will have to map it to the virtual volume name, which will be used for our subsequent activities. The activity goes like this. So the Cinder driver has instructed to create a volume and present it to this particular instance, and this instance is booting from the volume. The subsequent steps are to configure this volume in a replication, synchronous replication, and export this LUN from the secondary storage system to the compute host. And once that is done, we should be able to see the primary and the secondary storage system paths on from both the storage on the compute host. And this would be the critical step, so that when there is a failure, we should be able to fail over seamlessly if there are any issues underlying the storage actually. And we'll also simulate a failure subsequently, just to simulate a failure on the primary storage. And so probably we'll just go over this demo, which should help you understand whatever the process and actions that we are talking about. I'll just share my screen. So this is the primary storage. Rack C is our primary storage, and we have the Rack A as the secondary storage system, and we also have a quorum witness configured.
So to relate back to the diagram I showed, rack A is your 3 par 1.
3 par 1 and rack C is
3 par 2.
Yeah. No, rack C is 3 par 1 and rack A is 3 par 2.
Okay.
Just to correlate. So as we discussed about it, the first step would be to identify the LUN. Basically, what the LUN that was created from the openstack, basically the Cinder driver. So all the virtual volumes that start with OSV, they are basically the openstack volumes and have this naming convention by default. So there is a command that probably you could just run, show vv minus show calls name comment. So whatever the volume ID that we got from the Cinder dashboard or the Horizon dashboard, that would be mentioned in the comment section of the volume. So I'll just run this command on the primary volume actually. Okay, so this output will be quite cumbersome actually. So this, if you pay attention to the notice, if you pay attention to the comment section here, you have a section for volume ID. So we have identified that LUN as JU7W. Yeah, this is the LUN ID, volume ID that we were referring to in the Cinder or from the Horizon dashboard, and the associated virtual volume name is OSV. Yeah, typical naming conventions actually. So JU7W is our volume that we will be replicating to the secondary storage system. So the next step would be to replicate this particular LUN to the secondary storage system. So what we do is I'm using SSMC to demonstrate the replication configuration so that it would be easy for many of the audience. So the first step would be this is my source system, and I would choose the group as SerOS test, and remote volume I will say that it needs to be created automatically, and I'll choose the CPG, and this is the target system, and the mode is again synchronous. It has for peer persistence configuration, you need to have a synchronous replication mode, and I'll choose the same user and copy CPG. So you are also presented with an option of peer persistence. You have an option to enable path management, which is required for peer persistence. So I'll choose these two, and I'll add the source volume. The LUN is JU7W. Yeah, this is the LUN, and we'll say add. Then we'll just create the replication. So we'll just wait for this group to be available and start it. So this is the replication group or copy group. Okay, so now we have the status as normal, and it is in the replicated state, and it is in, what this means is it has also completed the sync. So we can also verify the same from the CLI. We can just run a show or copy command. and synchronous test. This is the remote copy group, and it is in the started, and this is the primary array, and you have the same thing on your destination. Yeah, this is the server's test, and this is the volume associated with it, and it is also in sync mode. So the next step would be, so going back to the steps, we had a LUN that was created from Cinder. We created a replication group for it, and that LUN is also replicated, and we have an ideal state. The second step is export this particular LUN from the secondary storage system to the compute host. So I'll again go back to SSMC. Yeah, let's go back to the virtual volumes. So this is the virtual volume that is part of replication, and this is the LUN that we had from the primary, and the system is 6L. So I would just export it to the second, from the secondary system to the host, the compute host. LUN ID is not mandatory, so it would just take that as an auto, and so this LUN is exported from the secondary system as well. Now we'll go to the compute host, and we'll just run the SCSI bus rescan. Now we should be able to see the paths from primary storage and as well as the secondary storage. So the scan is completed. So I'll just run multipath space -ll command on the compute host. So this is the LUN, and yeah, this is the, you can also map this particular LUN from whatever we had it from 3PAR from the multipath output. So I'll just run show VV -t. So it is 69, and we will map this LUN here. Yes, so this is the LUN, and we have the paths from the primary storage is active and ready in the ready state, and paths from the secondary storage is inactive, and as well as the status is ghost. Okay, now so we have completed the prerequisites and as well as configuring the replication for the LUN. So now we can just simulate a failure and verify if peer persistence is able to handle the transparent failover so that the VM continues to stay up and running. So before we do that, we will just try to do a SSH to the virtual machine. Okay. IP is 10.10.53.
So right now Bhaskar is going inside the virtual machine which Sunita just launched using the floating IP.
Okay. My mistake. The IP is 40.53. Yes. Okay. We are in the instance. And we can just run a dd command. We'll just create a random file and just to have this running on the guest instance or while we do the failover, basically simulate a failover. So the first thing would be to simulate a failure. We would bring down the replication ports and also we'll also disable or basically the primary storage will configure the IP tables basically to drop the connections from the primary storage. So I'll just go ahead and disable the ports.
So Bhaskar is basically simulating the 3-par failure. In the diagram, if you remember, 3-par 1 failing, exactly that thing he's doing.
Okay, now we have simulated the failure. We'll run the show or copy. Yeah, so it is in the fail-safe state, and we'll go to the secondary storage system. Yeah, we'll just connect from the secondary storage system and then we'll verify the status, and the volume is primary reverse, which is expected, and now we should go back and verify the status of the VM. Okay, actually the dd command got completed, so we'll increase the count while failing back and then we'll verify the status. So the file contents, I mean basically the VM is still up and running. So what I mean to say is even though we simulated we had a primary storage going down, we still have the virtual machine up and running, and I can also create a file. And I'll write some data into it. I'm just reading the same contents, just continuing to verify now that we are in the secondary storage system, just verifying the contents. As you can see, we were able to write to on the secondary storage system. I just wrote that test1.txt and we are able to read it, and I'll also try to read the file from the primary learn, basically the sample that was written using the dd command. So this seems to be working. So I'll just terminate this. So effectively what we can conclude is the system has the instance has survived the storage failure, and it is seamless for the VM to continue to run up and running no matter what happens in the infrastructure layer. Okay, so now we can restore back the production as it is, and I'll just restore the product replication from primary to DR site as it used to be earlier. For that, I'll just enable the ports. So I'll bring up the replication ports on the primary, and those are up. It would take a minute or two for that to get reflected. And well, this also will also enable the firewall rules. We'll disable it, and we'll just ensure everything is up. I'll just run the command again and verify the status. Yes, now the ports are up and running. And let's verify from the secondary storage system as well. Yes. So we can restore this back to the production, and I'll just run this rcopy group commands on it. Okay. So this is primary reverse, and let's go back here. Yes, so it is secondary reverse, it is started, and it is also synced. Now we will restore the connection back to the primary. Recover is basically we have recovered the system from the secondary storage system. Now we'll restore the replication direction as it was earlier. Yes, so the system is now secondary, and now this system should be primary. Yes, and we'll go back to the VM. And it continues to stay up, and no matter what is happening on this. So that's about showing the demonstration about peer persistence, failover, and failback.
Thanks, Bhaskar. So I think this was very useful, and hopefully the audience will find it useful. And if you have any queries, you can write back to us. Uh, uh, as I said, there is not much documentation around it right now, but hopefully in the coming months, this will be documented and shared. And we'll conclude this video right now. And very soon we are also coming up with a white paper around what we are doing. We will have this the reference of this video in that white paper also. Thanks everybody. Bye.